The purpose of the project is to design a search and rescue vehicle. While many existing vehicles will locate people in distress using a camera or heat, ours will be relying on auditory inputs from a microphone array of 4 microphones. An experiment to show how this works is to place a finger about 6 inches to a foot in front of your face. Look at it with one eye at a time, first your right, then your left. You will notice that your finger appears to be exactly the same and in the same spot, but the background has changed. Supposing that you could measure the displacement between the first and second viewpoint, in other words, the distance between your eyes, using basic trigonometry, you can then determine the distance and location of your finger. The same can be done with a sound and your ears. This is called binaural listening. You hear from 2 different locations. As you can imagine, as more auditory devices are added, the more complex the system becomes. However, the microphones are better able to detect the proper location of a sound, especially in a complex or otherwise noisy environment. While not all of these ideas were fully implemented throughout the semester, progress was completed towards the final goal.
My portion of the project was to construct the car. And to start off, I got popsicle sticks, hot glue gun, built to build the car. And the car had to be constructed, hold the breadboard, the MSP 430, and a power battery. So for the wheels, I thought to get a toy car, use those wheels, and then whatever motors came in there with that toy remote controlled car, I would use that towards the project, which worked out very well. But then after that, the project needed to be constructed with more care because it was not withholding what the car needed. So that was my portion for this project.
In order to rebuild the project, I got a servo motor to drive the steering, a power bank, and a cardboard box to hold all of the electronics once finished. For the electrical portion of the project, I began by ordering microphones from DigiKey. The first batch of microphones didn't work, so I ordered another kind, which I was able to get to work. However, on the output, the DC voltage was high enough to damage the MSP 430's pins, and the AC voltage was too low to be easily detected. To solve this issue, I designed a single-source amplifier which would step down the voltage while amplifying the AC signal. While this functioned flawlessly in simulations, it did not work in practice. Therefore, I obtained pre-made microphone amplifiers and used those. Here is the setup of the microphones before they are put into the car. So we have all the 4 glowing green dots you can see are the microphones that will be on the north, south, east, and west orientations within the vehicle. And on the oscilloscope in the background, you can see the waveform exported when I speak. As I get closer and louder, their highs get louder and higher. However, here's where I messed up. I turned the sensitivity nearly all the way up so that when it hears any sound, it becomes nearly maxed out. This is what looked best on the oscilloscope, but does not work best in real life. However, it is still able to function and feed useful information to the microprocessor to complete the project.
Hi, I'm Leo Herrera, and I will be talking about my portion of the project. So what I basically did was a software and algorithm for the autonomous vehicle. The way how it works is like so. There are 2 MSP 430s on the vehicle. One takes the input from the microphones, and then the second drives the direction. The way how it works is like so. The first MSP 430 will take input from all 4 microphones. It will then determine the loudest one, and then by knowing where each microphone is, we'll say which direction does it need to go to, north, east, south, or west. From there, it uses UART, a serial protocol to communicate between the 2 microprocessors, to then relay that information from the input from the one MSP 430 to the second MSP 430. That second MSP 430 will then take the direction and then change accordingly depending on where it needs to go. If it needs to go straight, the servo will center itself and it will just go straight. If it needs to go backwards, the direction will change. If it needs to turn, the servo motor will turn to change. And yeah, that is it.